Hi, so we're going to do number 6 of worksheet 6, which is another Hesses Law problem. And our goal equation is N2 plus O2 yields 2 molecules of NO. And we don't know the heat of the reaction for this, but we're given 2 reactions. We're given 4 NH3 plus 3 O2 yields 2 N2 plus 6 H2O. And we're given the heat of that reaction is negative 1530 kilojoules. And then the other one we're given is we have 4 molecules of NH3 plus 5 molecules of oxygen yields 4 molecules of NO plus 6 molecules of water. And the heat of that reaction is negative 1170 kilojoules. So one of the things I notice is that I need to get the N2 on the other side of the equation, because here it's a product, but I need it to be a reactant. This other equation doesn't even have nitrogen molecules in it, so I can't use this one. So I know I have to reverse this one. I have to reverse the whole thing in order to get the nitrogen into the reactants. And then the other thing I notice is that I have too many nitrogens. But if I divided the whole thing by 2, that would give me the right number of nitrogens. So my plan is I'm going to reverse this reaction, and I'm going to divide all of the coefficients and the heat of the reaction by 2. For this one, well, I see that I have got oxygen, and I see I've got 4 NO, and the NO is on the correct side. I don't want to change the side of the NO, because it's already in the right place, but I have too much. So I thought, well, what would happen if I just chopped everything in half? So I took the whole equation. I didn't reverse it, didn't monkey with it that way, but I took the whole equation and I multiplied it by 1/2. And whatever I do to the chemical equation, I also have to do to the heat of the reaction. So when I reversed the first equation and divided everything by 2. I rewrote it, and now my nitrogen is on the correct side, and instead of having 2 nitrogens, which I started with, I have 1. Instead of having 6 waters, I have 3. Instead of having 4 ammonia, now I'm producing 2. And instead of having 3 oxygens, now I'm saying I produced 1.5, because 1.5 is half of 3. And whatever I did to this whole thing, I also did to the heat of the reaction, which means that I multiplied this negative 1530 by negative 1/2, which is what I did to this one. So when you multiply a negative by a negative, it gives you a positive. And basically it chopped the value in half. So now it's 765 kilojoules. This one, my plan was to divide by 2, and that's it. So I took my 2 ammonia and my 2.5 oxygens, yields 2 nitrogen and oxide, and 3 waters. Now I'm going to try to combine these. So wherever I can, I'm going to try to cancel out across the arrow. I see that I've got 3 H2O as a reactant on this one, and I've got 3 H2O as a product on this one, so those will cancel out. I see that I have 2 molecules of ammonia as a product here, and I have 2 as a reactant here, so these will cancel out. And then basically, these don't exactly cancel out, but you just subtract and get the difference. So I actually had 1 more oxygen on this side than in the products of this one. So that leaves me with N2 plus O2 yields 2NO, which was my goal reaction. And then whatever I do to my chemical reactions, I've got to do to the heat of their reactions. So this plus 765 kilojoules will be combined with the negative 585 kilojoules, which will give me a difference of plus 180 kilojoules for the heat of this reaction. So this reaction, the heat of this reaction, is plus 180 kilojoules, which means this is an endothermic reaction.